On behalf of 24houranswers.com, I welcome you to today's lesson. In this video, this is part 2 to integration by substitution and is typically called U-Sub or U-Substitution. In part 1, we worked this exact same indefinite integral out and we got this answer without doing any U-Substitution. We just did some algebra, a little bit of distributive property, and then we integrated this piece to get our final answer. Let's do the same problem using U-Substitution finally. And the big idea here is this. If you can see some function, for example, we see this piece right here. And if we take the derivative of this piece here, notice that the derivative of this, which is going to be 3x squared, actually shows up in this problem. And then we tack on the dx as well. And we're going to see that, and it's going to become very natural the more you practice U-Sub. So that first function right here, I'm going to let u be equal to x cubed minus 1. And then I want to find the derivative of u. We can write u prime, or typically we do write du instead, and you'll see why in a moment. So let's find the derivative of u, but we're doing it with respect to x, so we have 3x squared, that's the derivative of x cubed, plus 0, don't even worry about it, and then we're going to tack on our dx. So what I want you to notice is that this u is equal to x cubed minus 1. That's going to be everything inside of these parentheses here. The squared is still going to be part of our integral right here in a moment. The du is going to take care of the 3x squared right here and the dx, what we have over here on the end. So now what we want to do is we want to substitute this u and this du, these pieces here, for their corresponding parts. So recall u is equal to the x cubed minus 1, so we have u squared. And to make sure you understand that, all of this stuff is u. It's getting squared, so there's the u squared. Du takes care of the 3x squared and the dx. There's our 3x squared, there's our dx, so we can just tack on a du since du is equal to all of that stuff. Now we have an indefinite integral in terms of u that's really quick and easy to integrate. The integral of u squared is u cubed over 3 plus some constant c. And now to finish this problem off, we take whatever u is equal to, we substitute it back in, therefore we have x cubed minus 1 to the third power over 3 plus some constant c. And that is our answer. Now one may look at these two problems here and say, okay, well these don't appear to be the same. So I have taken those two answers that we have, I've left off the plus c, and you may say, well these two aren't the same. The only thing that differs by these two functions is some constant. So what I've done is I've added a capital C for f of x, that's some constant, and then I've added a lowercase c for g of x, that's another constant. And I can take this slider and slide that c around, and I can slide this c here as well, and notice if we slide it just right, somewhere right around there, two different c values, but it's only differing by a constant. I can slide these functions up and down and I can make them match up, and that's all about plus some constant c. So they are the same, the only thing they differ by is some constant. And if we think about this, if you went back and differentiated this or this, when you go to differentiate that constant, it's going to be 0, which is ultimately going to lead back to this same indefinite integral that we had up here. And there you have it. Finally using U-Sub. Again, it wasn't necessary for this problem, but in future videos it will be a lot easier. In this case here, it wasn't too much different. I mean, a little bit of algebra here and not as much algebra here. But again, when we start cubing things or raising things to higher powers, it's going to definitely speed up our process. And then later on down the road, we'll also see cases where U-Sub is absolutely necessary. There is no other way to integrate that problem. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.